Hi everyone, welcome to today's webinar, the next webinar in our HealthSpan Show series. Thank you so much for joining today. We've got a fantastic panel and a really interesting topic to discuss. Before we get going, I'd like to remind everyone, please feel free to use the chat to talk with your other attendees. If you've got any ideas or thoughts to share, we always love to see you corresponding in the chat. If you do have specific questions for our panel, please use the Q&A function. It's a much better workflow for them to be able to follow to address your questions as and when they come in or at the end. But without further ado, I'm going to hand over for today's discussion. We're going to be addressing how to access the consumer market for epigenetics and for measuring biological age. And I'm very pleased to hand you over to your moderator today, Tina Woods. Thanks, Tina.
Sorry, I'm on mute. Yes. So thanks so much, Angela. I'm really pleased to be here today with my panelists, who I'll introduce in a moment. So just a couple of words just on myself. So I'm Tina Woods. I'm the CEO and founder of Collider Health, and I wear a few other hats in the longevity space. And of course, I have a huge interest in living healthier, longer lives. I wrote about it in a book called Live Longer with AI. And in fact, I write a lot on epigenetics in the book, and indeed have interviewed some of the people here today. So as part of the research gathering for the book. So the topic of the session today is called How to Access the Consumer Market for Epigenetics and Measuring Biological Age. Biological age has started to enter the lexicon in the media, although there's still lots of question marks around it and what it means versus chronological age. So this is something that we'll explore in the session today. And we'll also explore, what actually is epigenetics. We know that there's a huge amount of really fascinating research taking place in science and genomics, which we'll explore. So we're going to explore a few sort of questions, and please do send your questions on the Q&A. And I have been fascinated by this field. I've been a guinea pig myself on a couple of genetics and DNA sort of lifestyle companies. So it holds huge promise, which we will explore. So with us today is our three people who are leaders in their field, and their organizations and their businesses are going back gangbusters, or is about to go gangbusters. So I've got Nathan Berkeley, who's the CEO of Mudo. I've got Tom Stubbs, who's the CEO of Chronomics, and I've also got Michael Gear, who is the co-founder of Humanity. So we're going to go around in turn. We'll let everyone sort of introduce themselves briefly, but really what we're going to do is have a conversation. There are many questions we've got up our sleeve, but I hope many questions will come from our audience. So I'm going to go around the table first. So Nathan, I'm going to start with you, if you'd like just to introduce yourself and a little bit about Mudo.
Hi there, yeah, my name's Nathan Berkeley and I'm the CEO of Mudo, and we're a big data analytics company underpinned by genomic science. We incorporated back in 2017 and we started in the world of elite athletes, and then more recently we've pivoted into the world of corporate wellbeing and hospitals. Thank you, Nathan.
Next, Tom.
Hi everyone, as Tina said, my name's Tom Stubbs. I'm the CEO and founder of Chronomics, and Chronomics as a company is a bioinfrastructure company supporting people with getting access to biomarkers, in particular epigenetic information to support people taking actions from biology. And my background's more on the science side of epigenetics and biological age specifically, so with PhD and postdoc in that space. So looking forward to the discussion.
Thank you so much, Tom. And finally, Michael.
Thanks, Tina. Yeah, so Michael Gear, co-founder of Humanity, and Humanity is an app that allows you to basically measure your biological age on one side and then start to see what actions you're taking each and every day and see which ones can actually slow down your aging. And the underpinning of that is these pipelines of these kind of regulated and very specific tests like epigenetics and clinical markers that allow us to kind of move those into algorithms that then can give you a biological age. So really interested to have the discussion.
Fantastic. Thank you so much, Michael. So we're going to talk a little bit about some of the developments in genomics and epigenetics, how business models are evolving with the times. Obviously, there's been the COVID effect, as it were. I think most people are becoming much more conscious of their health. And we're going to go into a little bit about sort of the ethics and sort of the integrity piece as well, because I know regulation is a big issue in generally in health tech and med tech. So we're going to explore some of those questions. But first of all, we're just going to ask a general question, because I think there's a lot of, I guess, myths and potentially misunderstandings about what this actually all means. You know, what is epigenetics? And actually, just before the meeting, I actually looked up, you know, in the simple English Wikipedia version of what epigenetics is and what it says, and I'm just reading quote unquote, but we'll have a conversation about this. So epigenetics is a study of changes in gene activity which are not caused by changes in the DNA sequence. It is a study of gene expression, the way genes bring about their phenotypic effects. So that's the simple version of epigenetics, but I'm going to go around and just have a conversation about what is epigenetics and why is it important? And what is your business actually trying to do by focusing on epigenetics? So again, I'm going to go in the same order. So Nathan, you first.
Yeah, I mean, I think it's a really good question. So what we're looking at is how our lifestyles and how things that we do in our life and our behaviors affect our genetics. So we know our DNA is fixed, but obviously what we eat, what we drink, how we behave, how we sleep, the environment, in our pollution levels, all of that has a massive effect on how our epigenetics is, and that has a kind of an underlying factor on how we feel, how we become ill. So it's really important to understand that we're all individuals. We know that genes are the reason we all look different. I think people actually don't realize that it means that we're all different internally, and the way we react and process our environment is very different. So it's really important, epigenetics, to understand how individuals react to certain things and how it affects our health and how it can improve us, and really more on the side, I think, of prevention, how it can stop us eventually, hopefully, needed a clinical intervention. I think epigenetics is a part of the jigsaw puzzle. It's not the whole jigsaw puzzle. It's about joining all of these things together and all the companies that are involved in it to come up with that final solution.
Thank you, Nathan. So Tom, I'm going to go to you. Maybe you can go into a little bit of details, especially around the science behind biological age and the use of like aging clocks, things like that, just because some people might have cottoned on to the fact that there's quite a lot of stuff happening in that domain. So from a scientific perspective.
Yeah, sure. So I'm glad we're defining epigenetics, because it's always something, even in an academic context, that's kind of argued over. From economics perspective, when we think about epigenetics, we're talking about how your DNA is controlled, and as Nathan said, how it can be impacted by environment and lifestyle related factors. And Chronomics as a company, and also when we look at things like biological age measured using epigenetics, really what we're talking about is how you can build predictors or biomarkers using modifications or chemical tags or changes to DNA, in the majority of cases, DNA methylation, to define measures that can be used to support people live healthier and longer lives.
Fantastic, thank you, Tom. And Michael, maybe a little word about how we can really make this accessible to the wider public. Also, you know, why is epigenetics really, really important to understand?
Yeah, I think I mean, it starts with the simplicity of just making sure that someone could go onto an app or a website and actually, you know, get access to the technology, which is something that, you know, Tom and Nathan and their companies do amazingly well, and that's what we're starting to do with humanity. I think as a pure data, because we're looking at digital markers as well, we're looking, you know, we're a bit agnostic to it, but if we want to talk about epigenetics, there's just so much amazing information in there, which you can probably start to just understand just by it tells you kind of which genes are kind of turned on and off. That already sounds like it's probably a lot of information there, but it's kind of like the upstream and downstream data, right? Because you can kind of start to understand what happened to that person's body in the past, and then you can start to understand kind of what probably will happen to that person, and then obviously across like health outcome data, that becomes really, really predictive. And so I think that's the important thing is to get it out at a cost that people can manage and to basically give them back value, because I think other industries have kind of started off and they've kind of had value propositions that were interesting but not meaningful, I guess. And so I think with epigenetics, we're actually going to see that, you know, the meaning is going to come much quicker than it maybe came with, you know, just DNA kind of genotyping. So yeah.
Absolutely. So I think, I mean, for me, I mean, I studied genetics, well, God, a long time ago. But I think for me, you know, a lot of people, and certainly the general public, a lot of people think, oh, well, you know, I was born with what my parents gave me, and there's nothing I can do about my genetic sort of legacy. But actually, what's interesting is just, and this is what the science is telling us, is really how much you actually can do to actually change the course of, you know, your genetics. So I think that's really fascinating, and that obviously the science is just showing more and more every single day. So I think I'm going to start with a very general question, because I think, you know, we all have seen how COVID has shown a spotlight on our health, and also how the wider determinants of our health, where we're born, our postcode, you know, our educational status, you know, all the wider determinants of health, as we say, have a huge bearing on actually our health trajectory, and of course our health status. And you know, there are things that we can control. There are things that are more difficult to control, because, you know, it's tough moving out of a neighborhood if you don't have the resources and all the rest of it. That might actually damage your health, for example. But but just a word on, I guess, just a general conversation of why COVID has shown the spotlight on the importance of our health, but also the role of epigenetics. So just a general conversation. I'll just, you know, turn to who wants to go first, basically.
Yeah, I think, Tina, it's a really good question. I think it's interesting now, if you kind of hear about the conversations people are having pre and post COVID. Now everybody's talking about, am I in that affected group? Do I have a high BMI? Do I have underlying health conditions? These conversations were never open and public before COVID. Everybody now has a real focus on their age, how healthy they are for their age. So why COVID has been a terrible thing, and a terrible thing for society, and quite sad what it's affected some families. I think, you know, if something good can come out of this, it's actually people are more concerned about their bodies, what they put into their bodies, and how their everyday life affects that. So I think whilst COVID has been shocking for most people, I think the good part is people are understanding DNA more. It's not seen as a dark science, because obviously that's how the research came around to find the vaccine. But I think it's really got the debate happening, that people are starting to show a real interest in what's happening internally. It's not just about how good my picture looks on Instagram anymore. People are starting to think, I need to understand my health and my environment.
Tom or Michael, any words on that?
Yeah, I think to kind of echo what Nathan's saying, but to kind of add to that, if you look at COVID and kind of the risk factors for disease susceptibility in that context, age, obviously diabetes, things like that, but also kind of lesser, or I guess waypoints on the way to kind of outcomes related to heart disease, etc., are also kind of coming to the fore as being putting you at increased risk or increased susceptibility. And again, going back to obviously, Tina, you talked about genetics and the importance of genetics. And yes, whilst there are genetic conditions that have really high penetrance, so if you have the genetic mutation or allele or piece of genetic information that's different or deleterious, then you will have the disease. For lots of these things, there's a very small component that is purely genetic, and the vast majority of that risk component is driven by that genetics in the context of environment, lifestyle, age, etc. So I think that's been kind of one part that definitely has aligned to epigenetics. And again, as Nathan's mentioned, I never thought I'd hear my mum to start telling me about viral strains and the importance of different, you know, subtypes and things. So there's definitely an increased awareness of RNA, DNA, nucleic acids, etc., that have come about from COVID, that I think is a really positive message for people, that this science is accessible. It doesn't need to be kind of inaccessible to the public. and that, yeah, we should be taking care of our health, and the ownership is on us, as well as, you know, the fantastic NHS that we have in the UK, and obviously other systems elsewhere.
Absolutely, and of course we've got Genomics England, UK Biobank. I mean, in many ways, the UK is very much, you know, leaders in the world. You know, we see that in terms of viral, you know, genomic sequencing and all the rest of it. And you know, so we've got actually some great strengths that we can leverage just even on UK soil. But in terms of applying this technology for improved individual and population health. But Michael, just a word, you know, just generally on increasing, I guess, access to all this, because I know, you know, there's a lot of technologies out there. I mean, in the end, we want this technology to reach the masses, and particularly for those who may not have, you know, the resources to buy, you know, expensive technologies. Where do you think all that's sort of heading in terms of access?
Yeah, I mean, I think there's two easy answers to that. One is, you know, as you bring more volume into any system, the price goes down. And so I think, whereas epigenetics right now might be at a certain price point, so not too high, but you know, it's definitely out of the reach of some folks. But clinical markers, you know, they might start at, you know, $3 or £3, but they, you know, they can add up very quickly, right? And so the beauty of epigenetics, I think, is, you know, as that price point comes down and you're getting into the tens of pounds, you know, the amount of information there, as long as you can basically extrapolate across those data sets if you have enough of it, right? You have the clinical markers, you have the epigenetics, and you start to, you know, connect between the two. So I think the future of that, as the machinery gets cheaper, the volume gets higher, the ease of access through, you know, services from the guys here, like that all points in my head to that, you know, in 5 years, epigenetics will look like the much more attractive option than, you know, possibly the, you know, running the blood sample through the Roche machine, not the name of the companies. I think the one thing I would say about COVID as well is I think and it was touched on, but the binary nature of health kind of got blown up finally, whereas we all knew already, but I think the general public didn't really think about it. And a lot of people wouldn't even talk about it this way, is that you're not healthy or not healthy. You're always on some, you know, level of spectrum. Yeah. And I think finally getting that into the kind of mainstream conversation will end up leading to people looking for ways that they can do something about their health. And then it's important to have services like ours that are sitting there waiting to kind of, you know, make it easy for them to actually start being quite enfranchised into their own health, as Tom said, you know, take control of it. So
absolutely. So I'm going to now, I remember a couple of years ago, I remember writing about, you know, this whole sort of genomics revolution at the time. You know, the sort of Ancestry and 23andMe, they're all kind of flying off the shelves. I remember the press was saying how DNA kits are the hottest selling Christmas gift, you know. So I think there's a huge kind of like rush to all this, and then it kind of went through different sort of phases. And we know that the early adopters are going to be buying this sort of stuff anyway. But just a word, and maybe just through the experience, just through COVID, I mean, how has this changed or influenced your business models, and how do you see this technology getting out there, you know, in the business world, you know, to consumers, you know, all the different, you know, so just a word on that, because in the end, we want people, you know, to have access to these technologies in whatever route possible. Nathan, do you want to speak a little bit about that? Because I know you've kind of gone through that whole kind of evolution as a business yourself, haven't you?
Yeah, sure. I mean, when COVID hit, we were very focused on athletes, the world of sport, gyms, health trust. 70% of our business overnight shut. And that was, you know, it's quite, as a business, you kind of sit there going, crikey, when's it going to come back? And the business pivoted massively, and we saw a completely new customer base appear overnight. We've doubled our growth during COVID. We've got 50 partners, 9 languages, 15 countries. So we've seen a real shift away from just healthy people looking to improve their sports performance and understand more about their body. Because traditionally, that was the people, I guess, that wanted to drill down a little bit deeper, look for those 1% to 2% gains, and look for any edge, whether that be science that can give them the edge, changing their training techniques. And what we've seen now, I think, with COVID is a whole new customer has come to the forefront, which is families, general people, not necessarily people that we kind of we kind of associate with health and lifestyle that would push a market. It's a lot more generalist. And I think the demand's going through the roof at the moment, which is great. I think the key here is, people track a lot of information, and Michael's probably best placed to sort of talk about this. It's all about owning your data, owning your life, understanding more about that data and how much we collect, and the impact of all of those those push points and those data points. So for us, yes, COVID has completely changed our business from where we were 12 months ago, which was definitely 100% more focused in the fitness and athlete market, and it's completely changed since then.
Tom, do you want to say a few words on how things have influenced you?
Yeah, sure, can do. I think for us, COVID is from a business model perspective, it's really helped align and show us where as a company we can deliver the most value to people by focusing on supporting access to best-in-class biomarkers and solutions, epigenetics being an example of that, but also within the COVID space, whether that's access to sequencing solutions or just simply kind of PCR-based testing, etc. And more and more looking at the work that Nathan, Michael, etc. are doing. There's an incredible amount of science that needs to get out there and needs kind of vehicles to deliver it to users. And I think what COVID has also done is change the perception of how quickly science should get into the market. Over the course of COVID, we've seen, epidemiological based, you mentioned, kind of COVID sequencing based approaches that previously had been, I guess, very kind of nuanced or siloed. Now, for instance, in the UK, being offered as a general part of travel in order to kind of track how things are performing. And, I think the speed at which that's been implemented is something that wouldn't have been envisioned pre-COVID. And I think we're going to start to see this appearing in a whole host of other fields now as well. Why has it taken so long to bring science to market? So I'm pretty excited about that.
Yeah, I mean, it's opening up this whole notion of citizen science as well, which is fascinating. But so just from so Chronomics, you can download it. It is accessible just for anyone who's interested to download. Just like, because I know Mudo is, but I know Mudo is also offered through companies to through the sort of B2B sort of channels. But what your app is, how does it work?
Yeah, correct. So users can access testing. We also support partner organizations with delivering biomarker solutions through their products to serve, the use cases and needs that their users have. So yeah, both are there.
It's one of the things I've noticed is a trend, and I've been, sort of various sort of investors and other groups have approached me, sort of wondering, where are these clinics where I can get my biomarkers tested, and and they're starting to emerge. We're starting to get clinics who are kind of going into that sort of preventative health space and indeed that kind of longevity space, but it's still fairly early days, but it's starting to happen. So there's definitely something in the air that's changing things. But Michael, just a word from you. I mean, where do you see your, because I mean, you're a little bit earlier stage, I know, in your journey with the business, but where do you see your product being made available?
Yeah, I mean, we, Pete, my co-founder, and I, we never did any, we're consumer tech folks. We never did any service that wasn't global. And so we actually came into doing something slightly with an offline component with a little trepidation, which would probably rightfully so. And so we definitely see kind of our coverage being global, where you're using the digital markers that are coming in through the phone to get a biological age, and then basically going country by country and building up the infrastructure that we can work with partners. Where we can allow people to get those higher level tests with the clinical markers and the epigenetics. I think what we've seen is that we felt it was happening beforehand, with biological age starting to be kind of the darling of health, as in like it's a fantastic holistic way of just thinking about your health. But with COVID, we have like 10,000 people on our waiting list now, and we're bringing them off very quickly. It was just kind of an explosion where finally this idea that health is not running a fast mile or doing something like that. Health is like, is my body fully functional, and am I resilient to the, you know, the things that can happen to me in life. I think what we'll see going forward is being super open and collaborative, as you know, Tina, with a lot of the data, keeping the privacy of the data, but allowing all these different partners to start to learn from it. And I think that explosion of people going directly to these different services and getting these tests and learning about their own health will also lead to an explosion in understanding of a lot of the stuff that's been happening to everybody, you know, for the last, you know, thousands of years. And now we're finally going to have much more data points and be able to see, you know, what's causing what illness, what's, you know, early detection, you know, all these things that we're already seeing in the epigenetic market, you know, with things like Grail and others. So.
Absolutely. Thank you, Michael. So I'm going to pose a question, because I think it's something that keeps on coming up, and again is part of the language of how we talk about this. So we've talked about biological age, and that's, I guess, in simple terms, is, I guess, a measure of your innate sort of health status and how well you're doing in terms of your health trajectory versus your chronological age. So just a word on really clarifying what this means and why biological age is really important, going back to like the terminology of things, because I think and for people, I guess, to understand what they can do to keep either, you know, if your biological age, say, you know, you measure, you know, 50 and actually you're only 45, what you can actually do to reduce your age so that you become healthier. What are some of the interventions that, from your experience and what the data and what the science is telling us, are actually the most impactful? Obviously, bearing in mind, obviously it's unique to you, as it were. Just a quick word, I guess, around the table just about that, because I think biological age is starting to enter into the mainstream dialogue, and just so that people really understand what we're actually talking about and why it's important.
I might just say a quick, I think the guys will probably give a better definition than me, so I'll pass that one and let them do a better job. But I think that the important thing that we kind of need to move to, I think, as just a society, is we now have the ability to monitor our health on a personal level. And so using a lot of the methodologies that we had to use in the past, where we weren't able to monitor everybody, right? And so we had to come up with these general population advice, and as we've seen, that advice can change, you know, from decade to decade, and there's different reasons for that. But one of the reasons is, you know, it might have been true for 65% of the people, but it wasn't true for 35, and then they did another trial that simply had a different ratio of people. And so now we have the ability to monitor people. So we really need to kind of move from saying, hey, what's the best thing you can do to be healthy, is actually monitor yourself. And then here might be a list of things you might want to try, but you've got to see if it helps yourself. And you have that ability now, as opposed to, you know, just having to, you know, take the general population advice. So.
Absolutely. Any, Nathan or Tom, do you want to comment on this? Because I know, for example, I mean, I've tried various sort of kits, and and including Mudo, and I've been given a sort of almost like a recipe to follow for my own personal health and well-being, and how to either keep my biological age where it was, or indeed to improve it. So, and that was a raft of, you know, supplements, nutrition, exercise, you know, all tailored to my unique, you know, epigenetic sort of profile. So, Nathan and Tom, do you want to just speak a little bit more about that? You know, some of the case studies. I mean, I know, you know, it's really, really interesting to see, you know, and the surprises that maybe people aren't aware of how much impact, you know, what you eat and your lifestyle can actually do. Anyone want to have a go at that? Tom?
Sure. As well, kind of just, I guess, touching on the question that Michael kind of artfully dodged around the kind of chronological age versus biological age, and obviously to Michael's point, you know, biological age can be got at in a number of different ways, from looking at clinical blood biomarkers, etc. But from an epigenetics perspective, it's really capturing the dynamics of DNA methylation change, or how your DNA is controlled and how that's changing and evolving with age, in a kind of entropic sense as you get older. And so it really is capturing at a molecular level that aging process. So instead of kind of candles on a birthday cake, it's really looking at your internal system and how it's performing as you move through time, which I think is, you know, incredibly exciting, and to Michael's point, opens then up windows for each of us at a personalized level to start to look at how we can perturb that to the benefit of ourselves. I think also in terms of what this information can do and where it will position us towards in the future. I always think of this as, we're in a similar situation to where we were from a more traditional disease-based context, perhaps many years ago. So for instance, taking something like cancer, kind of having the ability to look at different subtypes and then define specific treatments off the back of it, the default would be, okay, right, this is, this person has potentially cancer, let's give them chemo. And now we've got much more kind of exquisitely precise on kind of what you can do in terms of treatments to support somebody with that condition. I think the same is true in a health context. As Michael said, kind of up until now, there's general frameworks of advice that may or may not hold up across different populations or subsets of populations. But now that we have these biomarkers and this information, we can then start to get more exquisitely precise on what any one individual can do to support their health as an individual.
Absolutely. So I think this whole idea of personalized precision sort of health is really sort of coming into its own. So we've just got a question here, which is really interesting, and I'll ask Nathan actually to answer, but I'll tell a little bit of a personal story as well to help elucidate the question. So that we've got a question here. There's clearly great traction in the development of consumer-based epigenetic tests, but how do consumers interpret the data and what do they do with it? And so it reminds me, the first DNA sort of kit that I tried out as a guinea pig, and it was in beta stage, it was very, very early days. I remember getting this report back, and it's none of the businesses here, by the way. I remember getting this report back, long detailed report full of all the sort of the mutations, and sort of it had a red and it had a traffic light system, red, green, and amber, and I had a whole bunch of reds, and I'm thinking, oh my God, what do I do about these red lights, And I sat with a genetic counselor for 2 hours who drew these very, very elaborate sort of pictures and all the biochemical pathways and all the supplements that I would need to take to be able to interrupt, or address, whatever deficiency there was that I had. So it was quite daunting and a bit fascinating, but I think things have obviously moved on a huge degree, and there are dashboards and things that really make it easier to understand what to do with this information once you've got it, but also what to do with it. So Nathan, can you tell me a little bit more about your journey that you went on? Because I know, I was struck by the dashboard system that you have that made it really, really simple. But just a word about that, because there is a danger of just too much information. You don't know what to do with it.
And I think both Tom and Michael have made two very good points that do actually lead into this answer, which is, you're collecting that science part, you're understanding why someone's genes are acting the way they are, and you're able to look at that. And then Michael's point is we need to understand you as an individual. So it's bringing out all this information in to understand from a huge population, from all this information, what is having an effect on each person's genes. So from our perspective, we purely report out on things that you can do an actionable intervention. I think the danger with genetics and epigenetics is just because you've got a predisposition to something, it doesn't mean that's going to happen. I think that's where epigenetics is important, which is what Tom was saying a minute ago. And then Michael, from understanding your lifestyle and those data points, is understanding how my life is affecting my genes and trying to make positive step forwards to make sure I basically play the cards I were dealt, because that's what your DNA is. That's what you were given. What's the best way for me to play the deck I've been given? So I think it's really important from a genetic perspective always to give people actionable interventions. There are companies out there who report out on lots of other areas, disease diagnostics, but if I don't know what to do with that information, we've talked about how epigenetics is how our genes are affected by our environment. Stress is a big part of that. By telling someone about something that they can't do anything about can create that stress and environment that then could be a huge trigger towards ill health. So I think it's really important that we talk about where we can do actionable interventions, and the work that people like Michael, Tom and ourselves are doing will help us see more and more data around that, how interventions have an impact and how people can positively change the actions around the genes. So it's not about how many genes we look at or how big that data set is. It's about what can I do as an individual to affect my health and to play those cards.
Absolutely. So I'm going to go into, I guess, again, another, we've got another question here, which I will ask now. So with respect to reversing your biological age, what is the link between diet and the epigenome? What is the mechanism? Who would like to have a stab at that? Tom?
Yeah, sure, I can do. So I guess kind of maybe take two pieces on this. One is that, if you look at biological age measures using epigenetics, components of diet have been shown to accelerate epigenetic age, but also to decelerate it. So there's kind of direct correlations at that level. But in terms of kind of diving in mechanistically in terms of how is diet linked to epigenetic modifications, etc., or these chemical tags in your cells that are either on your DNA or on proteins that are packaging that DNA, etc. Essentially, those are all modifications that are feeding back from pathways linked to metabolism, so linked to, for instance, 1-carbon metabolism and other forms of food processing, if you like, at a chemical level that's happening inside your cells. And so the actual, very nature of how epigenetics is added or taken away or is very much related to the nutrients and the environment in which those cells are operating. To take an extreme example, the metabolism of embryonic cells is very different to differentiated cells. And if you look at the epigenetic profiles of those cells, they are completely kind of night and day different because of the completely distinct nature of the nutrition that those cells are getting. So there's really tight mechanistic links at a cellular level, and also now at a population level, we're seeing those links play out from a biological age perspective and an epigenetics perspective as well.
Fantastic. We've got another question here about the microbiome, and I was struck by something I heard in the news the other day about how there's all sorts of twin studies, and of course Tim Spector's group is fantastic, doing amazing work in that respect. But two twins, identical twins, who obviously have the same DNA, if they have a different diet, and we've got this question on the microbiome, their response to foods that they eat will be entirely different. And so which is very, very interesting. So I think just a question on what role does microbiome play in this whole interaction of our body and our response to food. So does anyone want to tackle that question? Because it's really interesting. Microbiome is a fascinating subject in itself and getting increasing attention, and there's massive science behind that. Nathan? Tom? Oh, Nathan, you're on mute.
Yeah, sorry, I was going to say we don't look at microbiome from our perspective. I don't know if Tom does within his organisation.
Tom or Michael? Tom?
We don't currently look at microbiome. There is clearly lots of information and insight that can be got at from a microbiome perspective. I think from the data that we've seen anyway up until now, some of the challenges with microbiome have just been related to sampling or how you access that information. Without getting into too much graphic detail, if you're sampling stool, I think everyone probably on the call knows that from day to day it can be quite distinct. And again, if you're only taking a very small fraction of that to capture what is in the essence of that material. So there's challenges around kind of sampling the information, but absolutely, microbiome is an important facet of health. And there's numerous studies, I guess, looking at that, when you're removing it in model systems and the impacts of that to demonstrate that as well.
Thank you, Tom. We've got another question here, which I'll throw out. It's going back to the price of kits. Right now, it says the price for DNA methylation tests starts at a few $100s for consumers. What's your expectation for the timeline to drop the price significantly to something more affordable, like tens of dollars perhaps, assuming that price is the biggest roadblock to scale the use of the biomarker, or is that a wrong assumption? So do you see other ways to go around the price? So we do know that the prices have absolutely plummeted over the years. I mean, the cost of DNA sequencing have absolutely come down. But how is that going to feed into the price of consumer kits? General conversation around that.
Yeah,
Nathan?
I'm happy to start on that one. So I think if you look at where DNA went, people are looking at less areas, less SNPs, less markers, depending on where people focus. And I think the same will happen with epigenetics. Everybody tends to be using the Illumina 850 Epic array. It's a research chip. It looks at a huge area. It costs a lot of money to do because it is a research chip. I think as time moves on, towards the end of this year, next year, as more and more people do it, custom chips will come along where people are looking at less areas. We've already designed one. Ours launches in a couple of months' time. That brings down the price considerably. You still need that research chip running in the background because it's really important because we're still at the early days. But I think it will be you'll get areas where people focus on rather than looking at the whole spectrum, which is always going to be expensive at this stage.
Yeah, I'll add just because we've had a bunch of conversations with, Illumina and different, companies like Eurofins. And so I think in consumer tech, you definitely have, or just like e-commerce or any kind of like online, you have a ramped system usually. Like you'll get something for free, and then maybe you'll subscribe to a slightly higher level, and then you're ramped into the system. And then this is still the early days of kind of epigenetics, but it's more like you're hit with that, couple $100. And I think actually the idea of the custom chip, which Nathan brought up, that definitely is because the beautiful thing is you take I'll spell it out just because I know everybody hasn't really done this, is you take a sample. So let's say it's saliva or blood. You then do the DNA extraction out of that sample as it gets sent into the lab, and you can store that sample. You can store that that DNA extraction from that particular time point. You can very easily, and this is something that we plan to do as these custom chips come out, is you can very easily do a much cheaper chip, and you're looking at what you've seen to be the most important stuff, and then you have two options, right? One is that user might want to go back and learn more, and you could they can upgrade and pay more. Or it might be that maybe there's some huge research project that gets funding, and they need the UK needs to know more about this. The user can opt in to have the Epic run on their sample. And so I think as you see it with the genetics now, is there's tons of different ways for these things to be paid for. And as you kind of get below that $100 level or £100 level, the options are basically they're numerous. The one thing I would say, touching on that question though, is I think it's wrong to look at the price as the reason why not everybody's doing it, because that's going to lead us in bad directions, right? That you got to put more value on the other side of that price.
Yeah.
And as you put the more value on the other side of that price, and the price comes down, you get this beautiful kind of on ramp of the entire population. But you need to do both at the same time.
So I know this is before COVID, but I know initially there was talk, and this is all linked to the Genomics England sort of, genome sort of campaign, making it more accessible and even being able to offer DNA kits to anyone who wanted one, so to speak. So I think there's this move to try and make it more accessible in the general public. And I don't know what it's like around the world. And I know, Nathan, you're doing quite a lot of different studies around the world, but just a question on, I guess, where DNA testing is around the world, where it's really taking off, but also how it's opening up this whole notion around citizen science. And I know, Michael, you'll know some of the work that we're doing in terms of opening up access to, mega data sets and making them accessible in the big repositories of biomarkers, because this is where, the future of AI and really, really harnessing sort of multimodal AI and accessing, the insight across, disparate data sets really becomes very, very powerful. So just to comment on that, sort of which countries around the world are really embracing this? Where do you see citizen science going to really open up? And do you see your businesses all sort of, collaborating and making your data accessible, for the purpose of the wider sort of scientific good, as it were, and advancing, sort of research, etc. So just a general conversation around that before we close. Who wants to go first? Nathan? Because I know you're doing some interesting.
Yeah, I think it's a really question. We haven't really seen that one country's, taking up the opportunity more than others. I think what we're seeing is different types of people within those countries doing. I think it's a really good point that Michael made. It's, how much is your health worth? It's not. It shouldn't be about price point. And I know that's prohibitive to some people in some countries, or to some people, depending on how much disposable income they have. But it's more about what results am I going to get at the other end. And I think that's the important thing that's going to drive the market. For us, we're just seeing an absolute cross section. I think people have a perception that it's kind of the worried well that would probably be looking at this, and I'm sure the guys can interject as well, but I'm sure they've seen it's, young people are really it's amazing how they're one of the few generations that have got a real opportunity to change the world, and they're changing and bringing down structures that wouldn't normally happen. And part of that, I think, is putting science in their hands and moving it forward, their willingness to be part of that kind of great experiment, I think, to see how we kind of piece those pieces of the jigsaw together to become healthier. I know we started off talking about living longer. I don't think it's about living longer. I think it's about, while we're here, making sure we're able to enjoy that life and be healthier, so we're not a drain. Our goal as a company here at Moodoo is that we want people to be as active and as healthy in their 70s as previous generations were in their 50s. So I think that's really important. So we're seeing a cross section from all over the world. I don't think you can age group it. I don't think you can put it by country. I think people are genuinely really interested in their health. And go back to your point, is there ways to collaborate? I think the only way to move forward isn't about everybody competing. It's a huge market. There's space for everyone. It's about how we grow the market together, and educate people on why doing epigenetics, understanding your foundations, which is your genetics, is really important.
Fantastic. Tom, do you want to comment on that? And maybe just a word on, maybe some concerns also to widen it out, regulation, privacy, all that sort of stuff. How are you addressing that?
Yeah, sure. I think in terms of a data sharing or making stuff accessible, I think there's great strides happening globally, but kind of, I guess, being led to an extent by Europe from a data regulation around health data perspective, and definitely from our perspective, these data points are owned by our users. They're not owned by Chronomics or I can't speak for I guess Moodoo and Humanity, but that's definitely kind of the direction of travel. And we see that as a super exciting piece. Again, to Nathan's point around individuals being able to make the active choice to contribute, and going back to the impact that COVID's had, we do quite a bit of kind of research work with opt-in, kind of consenting individuals, and just kind of pre-COVID to post-COVID, the proportion of people that are consenting for data to be shared to support scientific advances and stuff is now like 90+% of users. And that has, I won't tell you what it was before, but it's massively kind of ballooned. So there's, definitely people are seeing the collaborative nature that science is, that that we need to be employing as society in order to bring these advances forward as fast as possible for the benefit of all. Absolutely.
So, Michael, just a comment on that, open innovation, healthy longevity for all. Where do you see that all sort of going? And then I'm going to just ask everyone to make, and then I've got one more question, but Michael, if you just go open innovation, healthy longevity for all, where you see that going would be wonderful.
Yeah. So I think if I was to leave the audience with kind of one or a couple of thoughts is that there is the ability to keep people's, data private and to still get learnings from that data. That technology exists. It's been scaled by many companies. And so it really is incumbent upon, government officials and us as founders of companies and of, everybody on the street to realize that value is sitting there kind of not being used. And we need to actually kind of push each of each other to like move forward and use this technology to start getting all those life-saving learnings from this data. And as Tom says, keep this data where it started with the person, their ownership, but still be able to kind of, train these different, life-saving models on top of it it's no longer that we need to make the choice between, privacy and saving lives. We can actually do both, and we just need to get the technology out there, which exists. So.
Absolutely. So I've just got this final question, which we'll ask. So yes, it's about bridging the gap with academic research. This is from a scientist who recently left academia. Notice academia is not focused on solutions, but publishing. So this is a question on, I guess, the outcome piece and the mission that I know all of your businesses are on to increase, healthier lives for all. But just a final word on that. How can we bridge and how can we work together more collaboratively with academia on the broader goals? So a final word on that, and then we'll close on where the future is on that point. Anyone would like to start? Nathan?
Yeah, I think it's a really good question, actually. And I think, the days of academia just being kind of kept in a petri dish in a lab, certainly if you talk to universities today, the way a lot of lecturers, professors and doctors in those universities, they're actually asking, is before we do the science, is there a real world need for it? What's the driver for it? And I think we're looking more and more from a science perspective. So do people want it? Is it going to have an effect on society? If so, how do we get it out there in society? We very much came from the commercial model first, we're a business. But actually now, a lot of our work is actually now working with academia. They've seen that the product's used in real time, is used by real people. So actually now we're partnering with that academia. The big project we have with the National University of Singapore, another one with Angela Ruskin, and another one that's going to be announced later this week, which is huge about population growth, longevity, where they're using our platform, their abilities within those academias to then work with commercial businesses, because ultimately without the likes of Michael, Tom, myself and companies like us, if we don't push this forward and educate the general public that it's available to them and they help to drive the need and the necessity, we won't get enough data to drive the science forward. So it's got to be used by a lot more people to get that out there. So I think there is still a big place for the two. I think they're working more and more and collaborating more and more.
Fantastic. Any final comments on that? Tom, did you want to say a quick word on that?
Yeah, sure. Happy to. I think, from my perspective, I guess to Nathan's point, there's kind of that traditional academia, and as I think the question said, of the incentives are clearly around publishing, and I guess there's more incentives now being introduced from bodies that are funding agencies, etc., to introduce a translational element. I have to say, even just kind of coming full circle to biological age and some of the work that I did in a kind of previous life on this stuff, not all of it for sure would be deemed kind of translationally ready, or even necessarily look like it has an immediate application. But I think what we are seeing now, to Nathan's point, is that this isn't just a one-way door where stuff leaves academia, goes out into the world, and somebody's got to go to academia, pick it up and drag it out there. You're seeing kind of much more fluid nature, I guess, of academics translating stuff into industry, and also looking at the kind of the data science aspects of this, things that everyone's talked about on this call, taking some of that back into academia or academic context to get further validation or to build out potentially therapies or treatments off the back of stuff. I think we're definitely going to see much more of a kind of two-way street happening in that regard. So I think it's an interesting time ahead, but there's definitely value in kind of serendipitous things being allowed to continue in academia for sure.
Absolutely.
You never know where they'll take us.
Absolutely. So we're going to close with the final question, I promise, because we are running out of time. So the final question is, how many miles do you think we all have on our clocks? With perfect health, what's the upper limit? So I'm going to go around. Michael, you first. What's the upper limit if we really get this right? Healthy, happy, long life.
I mean, mechanistically, there isn't an upper limit. Where do I think the people on this call got on? I'll probably keep that to myself, but I think we're going to get far. I think generally, since we're starting to have these mechanisms of basically trying things in our lifestyle and then being able to see if it's working or not, as that goes out with humanity and then Mudo and Chronomics, I think we'll see that people's upper limit and their functional years will start pushing out pretty quickly. And as I think Nathan touched on earlier, you know, everybody that was born, that was, you know, not that I want to say that I'm old, but, you know, people that were born maybe like a decade after me, like every single one of them believes they can change the world because they've had repeated experience of being able to do so. And I think that expectation will actually lead to them doing a lot of stuff that will push out their upper limit quite a long way. And hopefully we can go on that ride with them. So
fantastic. Nathan, what's your answer?
Yeah, I'm Michael. I wouldn't like to put an age on it. Also, knowing my youth, and I think, look, for me, it goes back to a point I made earlier, which really, for me, it's not about how old we're going to get to. It's quality of life. I think we've got to stop looking at how the aging population, how old we're going to be. It's about quality of life. How can I actually enjoy my life? You know, the working age is going to increase and increase and increase. We're going to be working a lot longer. The pandemic's not helped that. It's had a seismic effect on economies, people's businesses, and people's ability to earn. So I think we need to kind of focus. You know, the word longevity is great, but we need to focus it back on, it's about quality of living. We saw the strains of our health services it's been put under during the pandemic. And actually, you know, if we all look after ourselves a little bit better, it takes the strain away from the health service, but it also means we're going to have a happier life because we're going to live it better and enjoy it more. So I think for me, it's the quality of the life rather than how old I get to.
Yeah. And Tom?
Take a different angle on it, I guess. Yeah, it's always amazed me when we, you know, talk about aging as this kind of inevitable process, when actually, as living beings, you know, from one generation to the next, there's no kind of death that's then a rebirth. Like it's a constant transition of a living entity that's, you know, taking different forms over time. And there's already research that's being done from an academic context to re-engineer that without the rejuvenation components, the rejuvenation, to get the rejuvenation components without the reprogramming components that happen across generations. So I'm with Michael on that one. I think we're already there. We just need to change how we think about it.
So yeah, absolutely. So I think, you know, I mean, there are quite a few scientists in the longevity space who are already starting to say that we'll reach longevity escape velocity, which is a term coined by Ray Kurzweil, and that we would achieve it by 1945. But already they're saying that will go down because of the advance of science and able to understand how to unlock the mystery of aging and to actually intervene with the aging process. But I'm with Nathan on this idea of, you know, I think the quality of our life and the happier our lives are is actually really the ultimate human goal in all of this. Who wants to live a very long life if it's crap? So I think, you know, so I think we can all agree that a healthy, happy life is a fantastic objective to work to. So I think we've run out of time, but this has been absolutely fascinating. And thank you so much to our audience for your questions. And thank you so much to Nathan, Michael, and Tom for your fantastic contributions. And over to you, Angela.
Thanks, everyone.
And thank you, Tina, for wonderful moderation as always. Look, thanks so much to our panelists again, and thank you to all of you for watching. I'd love for you to join us at our HealthSpan show in May. We will be addressing both of these concepts around both quality of life and how to improve that. We also have a debate between two faces I'm sure many of you know, Aubrey de Grey and Jay Olshansky, talking about that very question about the limit to longevity. It's going to be a very interesting and contentious debate. So we'd love to see you all there. I've put a link in the chat. Please sign up. It's free to join us. Our panelists will be back and we'd love to see you all there. But in the meantime, thank you once again to Tina and our panel, and goodbye.